Okay, thank you all for joining. The first thing to go over, hopefully you've gone through the before we start page, but I just want to highlight the help function. So if you are needing some help with Python, you can type help and the open close brackets, as well as posting in the chat and asking any of us. So we will start with the short introduction to programming in Python. So Python is an interpreted language which can be used two ways. You can use it as an advanced calculator, so executing just one command at a time, or you can use it in the terminal, although today we'll be using Jupyter. So we can assign values to variables in Python, which is one of the most basic things we can do. So for example, we can define text. And a number. And a value for pi. So here we've assigned data to each of these variables under text, number, and pi value using the assignment operator, which is the equal sign. And if we want to review the value of a variable, we can just type its name. And pressing Shift-Enter in the Jupyter notebook then prints out that value that we assigned to text. Everything in Python has a type. If we want to get the type of something, then we can just use the word type. And that returns str, which stands for string. Ray or Nathan, are one of you able to help one of the students?
Yep, I'm on it.
Thanks. We can check the types of the other ones that we've made. Oh, my mistake. There we go. So the number value returned integer. This one returned string because I had entered a string here. So that is something to be aware of. And then we can also check the type of pi value. And that gives us back a float. So the variable type for text is a string. These hold sequences of characters, which can be letters or numbers, punctuation, or more exotic types of text, like an emoji. And we can also see the value of things by using the print function, which then just prints out what it is that we stored in the text variable. This might seem redundant compared to just typing text in order to see what we'd stored there, but if you're running a script from the terminal, then using the print function is actually the only way to see that. If you just wrote this word, you wouldn't get the output. So print and type are built-in functions in Python. Later on in the lesson, we'll introduce methods and user-defined functions, and the Python documentation is a good way to reference the differences between them. We can also perform mathematical calculations in Python using the basic operators addition, subtraction, division, the star symbol for multiplication, and the percentage sign for the mod function to get the remainder. So we can do 2 plus 2. We can do 6 times 7. We can do the power function by using 2 of the star symbols. And we can do the modulo, which tells us what you have remaining if you divide 13 by 5. There are also comparison and logic operators in Python. Greater than, less than, is equal to, is not equal to. And we can also use the statements of identity and, or, and not, and that will return a Boolean. So if we write 3 greater than 4, it returns false to us. because 3 is obviously not greater than 4. And we can do other checks like this. And that's sorry, 1 second. Lists are a common data structure to hold an ordered sequence of elements. Each element can be accessed by an index, and it's important to note that Python indexes do start with 0 instead of 1. So if we create a list called numbers and populate it with 3 numbers, and then ask it to give us the first element of the list, it will return 1. So 1 is in the first position, which is indexed by 0. We can use a for loop to access the elements in a list or in other Python data structures one at a time. So this is asking for each item in the list that I've created called numbers. Will you print me that item? Which it then does 1 by 1. Indentation is very important in Python. So if you look at line 16, entry 16 here, you can see that the second line in the example is indented. This is telling Python that it's a block of code. To add elements onto the end of a list, we can use a method called append. Methods are a way to interact with an object, like a list, for example. And we can invoke a method using a dot followed by the name of the method and a list of the arguments in parentheses. So to make this clearer through an example, I call the object, which is my list that I created here, and then I use the dot to indicate I want to do something to that object. And I want to append something onto the end of it, so use the word append, and then we open parentheses. I type a 4 because I want to add a 4 onto the end of my list, and then I close the parentheses, sorry. And then if I print my new list, it should have a 4 now on the end. To find out what methods are available for a certain object, we can use that help command that I mentioned earlier. So if I type help and then the name of the object that I want help with, it will tell me all the things that I can do to it. Is everybody able to hear me?
I just come back, but yes, I can hear you.
Okay, good. Okay. I mean, not good because somebody can't hear me, but at least it's not completely broken. Okay, another type of object is tuples. So a tuple is similar to a list in that it is an ordered sequence of elements. However, tuples cannot be changed once created. They are immutable. Tuples are created by placing comma separated values inside parentheses. So an example of one is this. So when we create a tuple, we use the round brackets, the parentheses, as opposed to when we made the list where we used the square brackets. And we can make another one. Yeah. Cool. So we can put anything into the list. Here we've got integers, and here I've put strings, but these are both tuples. So there's a little exercise here for what will happen if you execute these things. So if everybody in their Jupyter notebooks wants to create the lists and tuples, I'll bring it onto here so you can share it. So if you want to set up the a tuple, another tuple, and the list, and then do this exercise, we'll check in about 5 minutes that you've managed to do it. And feel free to message if you have any problems. Okay, so if we look at the solution, hopefully everybody managed to get that. So when you type a_list1, so you're selecting the second element. Oh, no, sorry. When you type a_list and then select the second element 1 and equals 5, then you're going to replace the second element in the list with a 5. And if you try to do the same thing for the tuple, but with the third element, then you'll see that the tuple object does not support item assignment. So since the tuples are immutable, it won't let us change the value of that, unlike in the list. So elements in a list can be changed individually, but elements in a tuple cannot be. If we ask Python to tell us about the type of a tuple, it tells us that it is an object of the class tuple. And if we use the built-in function len, so like on the list object, it tells us the length of an object, and it works the same way for lists and tuples. So it tells us the number of entries in both, and it works, yeah, the same way on both of them. And if we type help on the built-in function len, then it tells us exactly what we discovered by trying these things out. So it will return the number of items in a container. This has also now told us that lists and tuples are both types of containers, so objects that can contain multiple items. The key difference being that lists are mutable, i.e. they can be modified after they've been created, and tuples are not, so their value cannot be modified, only overwritten. Right, I will move this back out of the way. And now we'll move on to look at dictionaries. So dictionary is a container that holds pairs of objects, which are called keys and values. So if I create a dictionary called translation, and then use that dictionary. So we've created a dictionary object called translation, and you can see that dictionaries are defined using the braces or the curly brackets rather than the square and the round ones that we saw previously for lists and tuples. And then within this, we define we index them with keys. So here we've got 1 as a key, and as we can see in this example, when we ask the dictionary to tell us what is associated with 1, it's the word first, and then separated by a comma, you can add another one, and you could add more things into the dictionary. So they work a lot like lists, except that instead of indexing it with a 0 or a 1 or whatever the element is, you index it with a key. So you can think about the key as like a name or an identifier for the value that it corresponds to. And then to add an item to a dictionary, we assign a value to a new key. So I'll just make this. So this one goes the other way around. And so we use the square brackets again when we do the indexing, but we use the word that we want rather than the number. And if we want to add an item to the dictionary, we can assign a value to a new key. So I can type the name of the dictionary and then the key, the new key that we want, and then the value that I want that key to correspond to. And now if I type rev and get it to print out the dictionary, it should have all three of the elements. So it's got the 2 that I assigned it originally, and then this third one that we added here. Using for loops with dictionaries is a little more complicated than what we saw with the lists. We can do it in 2 ways. We can do it this way. So here we can say that for each pair of key comma value in the items of the dictionary called rev, print the key and then print this arrow and then print the value. And then we can see that it's done that in order. Alternatively, we can try it like this. So this prints out the same output, but it's slightly different. So it's saying for every key in rev's keys, so the words first, second, and third, then print the key, print the arrow, and then print the entry associated in rev with that key. And we can see that gives us the same output. Okay, so we have another exercise, which is involving dictionaries. So I'll bring this over. So we're going to, so if you can make the rev dictionary, then print the value to the screen and reassign the value. Let me copy. Actually, yeah. So if you can, I've posted the Python, the line that you'll need to add to your notebook to define the dictionary rev with the 3 entries. And then if you do that and then do this changing dictionaries exercise, and yeah, if you have any problems, post in the chat and we'll go through the solution in 5 minutes time. All right, we will go through the solutions now. Good questions happening in the chat. So first, print the value of the dictionary to the screen. So if we just say print rev, then we get the whole thing out as expected. And then you were asked to reassign the value that corresponds to the key second, so it no longer reads the word 2, but instead the number 2. So the way to do that was getting the key second and then just using the assigning function, the equals function, to give us the number 2, and then by printing it back out, we can see that that is done. So hopefully you all managed that. And now we'll move to look at functions. So defining a section of code as a function in Python is done using the def keyword, def, short for definition, defining. For example, a function that takes 2 arguments and returns their sum can be defined as, if you just bear with while I try and type this as neatly as possible. So we're defining something called the add function. And we want it to return the summation of the 2 things. And then we can test it out. We will get 42. So we've created a function that adds 2 numbers, a and b, and then it returns the result of adding them. And we've created a variable called z, which is going to take on the value of the add function when you insert 20 and 22 and add them, and that gives us 42, which is what we would expect from adding 20 and 22. So a and b are the arguments that this function needs to take. So the key points from this section are that Python is an interpreted language which can be used interactively, where we execute one command at a time, or in a scripting mode where you create a Python script and then execute it. We've also been using Jupyter Notebook. One can assign a value to a variable in Python. Those variables can be of several types, such as string, integer, floating point, and we can even have complex number types. Lists and tuples are similar in that they are an ordered list of elements, but they differ in the way that a tuple is immutable, where it cannot be changed, and lists are mutable. And we've also looked at dictionaries, which are data structures that provide mappings between keys and values. So now we'll move on to the next lesson, where we'll be getting started with data. So we're going to be working with the Pandas data frame in Python, where we can automate the process of performing data manipulations in Python. It's efficient to spend time building the code to perform these tasks, because once it's built, we can use it over and over on different data sets that use a similar format. This makes our data manipulation processes reproducible. We can also share our code with colleagues, and then they can replicate the same analysis starting with the same original data. So we want to be starting in the same spot. To help the lesson run smoothly, we need to ensure that everyone is in the same directory, which will hopefully help us avoid path and file name issues. So at this point, can everyone navigate to the workshop directory? Hopefully you managed to do that at the start, but if you aren't there, can you go there now? And if you have a problem, just let us know in the chat. And make sure you've started your notebook in the directory so we can all see it. And for this lesson, we'll be using the portal teaching data, a subset of the data from Ernst et al., which was to do with monitoring of an ecosystem. And we'll be using files from the Portal project teaching database. And in this section, we'll just be using the surveys.csv file, which hopefully you've all got ahead of this lesson. We're going to be studying the species and weight of animals caught in sites in our study area. The dataset is stored as a .csv file. Each row holds information for a single animal, and there are different columns. There's a record_ID column, which tells us the unique ID for the observation, month for the month of the observation, day for the day, year for the year, plot ID, which gives the ID of a particular site, species ID, which is a 2-letter code, sex, which is the sex of the animal, M or F for male or female, hind foot length gives the length of the hind foot in millimeters, and weight gives the weight of the animal in grams. So the first few rows of the file will have the column headings and then the numbers underneath. So a library in Python contains a set of tools that are called functions that can perform tasks on our data. Importing a library is like getting a piece of lab equipment out of a storage locker and setting it up on the bench to be used in a project. Once the library is set up, it can be used or called to perform the tasks that it was built to do. One of the best options for working with tabular data in Python is to use the Python data analysis library, which is called Pandas. The Pandas library provides data structures, it produces high-quality plots via matplotlib, and integrates nicely with other libraries that use NumPy or NumPy, depending on how you want to pronounce it, which is another Python library that uses arrays. Python doesn't load all of the libraries available to it by default. We have to add an import statement to our code in order to use the library functions. So to import a library, we use the syntax import library name, and we can also give the library a nickname to shorten the command. So if we want to import pandas, we type import pandas. So if we just did this, that would import the pandas library, but then every time you wanted to use a function within it, you would have to type out the whole word pandas, which could get a little, especially for longer library names, a little annoying. So if we then type as PD, that then means that if we want to use anything in pandas, we can just use PD to call it. So every time we call a function that's inside a library, we use the syntax library name dot function name. So by adding the library name and a dot before the function name, that tells Python where that function will be found. So every time we call a pandas function, we'll type PD dot and then the name of the function that's inside pandas that we want to use. So to get started, we will look at reading CSV data using pandas. So we'll begin by locating and reading our survey data, which are in CSV format. CSV stands for comma-separated values and is a common way to store formatted data. Other symbols can also be used, so you might see tab-separated, colon-separated, or space-separated files. Pandas can work with each of these types of separators as it allows you to specify which separator is used in your data. CSV files and other separated value file types make it easy to share data, and they can be imported and exported from many applications, including Microsoft Excel. For more details on CSV files, there's a data organization in spreadsheets lesson available on the carpentries. So we're going to use Pandas read_CSV function to pull the file directly into a Pandas data frame. So what is a data frame? A data frame is a two-dimensional data structure that can store data of different types, including strings, numbers, categories, and more, in columns. It's similar to a spreadsheet or a SQL table or the data.frame in R, if you're familiar with any of those. A data frame always has an index, which is still zero-based as across Python, and an index will refer to the position of an element in the data structure. So we can type pd.readCSV. So the PD comes from the nickname when we imported it. readCSV is a function that exists already inside the Pandas library. And then we tell it where to find the CSV that we want to read. Let me just give it a minute. There we go. So now we can see this output, which is from the CSV. So this column here is the index, and then we've got the column headings that I described earlier, and then the entries for them. So we can see that there were, oh yes, that's a good point from Marie in the chat. So if your files are in a different place, then you might need to put something here. Yes, I can zoom in. Is that better? Perfect. Yes, so we can see that there were, sorry. So I was saying you can, you'll need to add your path here to get the CSV, depending on where you opened your Jupyter. And we can see that there were 35,549 rows parsed, and every row has got these 9 columns. The first column is the index of the data frame, as I was saying, so that identifies the position of the data, but it's not like an actual column of the data frame. So it looks like this readCSV function has read the file properly, but we haven't saved any data anywhere in the memory so that we can work with it. We've just asked it to read it. We need to assign the data frame to a variable. And if you remember, a variable is a name for a value, such as X or data. And we can create a new object with a variable name by assigning a value to it using the equal symbol. So let's call this imported survey data surveys_df for data frame. And then we just repeat the bit that we had earlier so that we have got this whole file in memory. So when I assign this, it doesn't produce any output because we've just assigned this table to this variable. But we can view the value of the object by typing its name in. So if I now type surveys_df, it will print the same thing again that we saw there, but now it's been saved in the memory under this name, under this variable name. If the output is wide, if you've got like a narrow terminal window, then you might see something different as the data goes past. So you might only see like the last column if it's being cut to fit your window shape. But all of the data will be there. You can see that by, if you, at the end of the output, it should still have the number of rows by number of columns. So as long as yours says this, then it will have imported all of the right amount of data. We can also use the head function to just view the first few lines. So if we do this, then it will just print out the first 5. for us, and that's easier to fit in one window. So if we want to, oh sorry, I'm just going to take some water. If we want to explore the species survey data, we can use a type function to have a look at what type of object our surveys underscore df is. So we just do that again. And it tells us that it's a data frame, which is unsurprising, but we can see that this is how Python internally is referring to it as a pandas.core.frame.dataframe. So what kind of things does surveys underscore df contain? So there's a specific function inside data frames called dtypes that will answer that for us. So here we get a list of each of the column headings and then what type is contained within it. So it's integers for most of them, and then objects and floats further on. All of the values in each column will have the same type. So everything in the month column is an int64, which is a type of integer. Cells in the month column can't have a fractional value, which is why it's integers, whereas things like the hindfoot length and the weight, they could have a fractional value, so they're floats instead. The object type isn't a very helpful name, but in this case, it just represents strings. So for sex, it will be M or F. We'll talk a bit more about what the different formats mean in a different lesson. So there are useful ways to view data frame objects in Python, lots of ways to summarize and access the data using attributes and methods that are provided by this data frame object. Attributes are features of an object. So for example, the shape attribute will output the size, like the number of rows and columns of an object. To access an attribute, you can use the data frame object name followed by the attribute name. So if I do surveys df and type columns, then it will give me all of the column headings that we saw earlier. And methods are like functions, but they only work on particular kinds of objects. So the head method that we did here to view the first few lines, that works on data frames. Methods are called in a similar fashion to attributes, using the syntax where you have the name of the object and then a full stop and then the name of the method. And then you need open and close parentheses after that. So with a method, we can add extra information to control the behavior. So we've got another exercise to have a look at the data using these things. So I'll bring that over here like this. So hopefully everyone's got the surveys underscore df in their notebook. And then if you want to try out these attributes and methods to see what they bring you, and we'll have a look at the solutions in 5 minutes again and post in the chat if you have any problems. Okay, hopefully you've all managed to do that. We'll have a quick look at the solution. So as we saw when I typed it before, if we do the name of the data frame, surveys.columns, it will give us the names of the columns from the data frame. If we use surveys.shape, it will give the dimensions of the data frame in a tuple in RC format where R is the number of rows and C is the number of columns. If we do surveys underscore data frame dot head, that gives us the first 5 lines of the data frame, as we also looked at earlier, and those are annotated with the column and row labels. If we add an integer as an argument to the function, so inside the parentheses, it will tell us the number of lines to display. And if we type tail, it will show us the last 5 lines and behave similarly to the head method. So let's move this back over. I'll just type these in so that everyone can see in case you didn't manage to get it. So that tells us the shape, which is, as we saw before, 35,549 rows by 9 columns. And then we can have a look at. So if I type, when I did it earlier, it showed us 5, but then when I type 15, it shows us the first 15. Note that that means it only looks like 14 because we are indexing from 0. And if we look at tails, tail singular, sorry, and that's showing us the last 5 entries. Great. So calculating statistics from data in a Pandas data frame. So now we have read our data into Python, saved in the surveys_df object. So we can perform some quick summary statistics to learn more about the data that we're working with. We might want to know how many animals were collected in each site or how many of each species were caught. And we can perform summary stats quickly using groups. But first we need to figure out what it is that we want to do. So if we begin by exploring the data, by looking at the columns, so we get these again. Oh, I think somebody is unmuted. And then we can use this to get a list of all the species. So by using the unique function, that will tell us all of the unique values in the species ID column. So that we use PD for data frame, then unique, if I can spell it right, which is a built-in function. We want to do that on our surveys object. And then we can specify that we want all of the unique values in the species ID column, like so. So that then gives us an array with all of these two-letter codes, which are all the different species IDs. So now we will get you guys to have a look at the statistics. Bring this over. So yeah, in the next 5 minutes, can you have a look at how to create a list of unique site IDs, which is the plot ID column found in the surveys data, and give it a name, and have a look at the difference between these two things. Okay, so we'll have a look at the solution for this exercise now. So by using the unique function that I demonstrated before, but this time on the plot ID column, we can find out by either doing, so you can get a variable called site names, which will save all of the unique entries in the plot ID column, and then by using the len function or the size, you can find that there are 24 separate unique sites, and by doing a similar thing, looking at the length of the unique values of the species ID column in the surveys data frame, we can find out there are 49 different species. And by looking at the output from length of site names or the surveys data frame plot ID in unique, they'll both provide the same output. They are equivalent methods of getting the unique values. The nUnique method combines the count and unique value extraction, and it can help avoiding in the creation of intermediate variables like site names. So here we made something called site names, which gave us the unique values, and then we asked it to give us a length of that. Whereas by using the nUnique method, you do those two steps in one go, so it can save with creating more variables than you would like to be keeping track of. So hopefully that worked well for everybody. And now we're going to look at doing groups in Pandas. So we often want to, what's this? The return to 48 rather than 49. Oh, let's see what happens if I do it. Yes, let me do the species ID one. Okay, so if I do this one, that gives us 49. And then if I do it with the nUnique method, Oh yeah. I don't know why those are different. Do any of the other instructors know? Yeah, I was wondering about the NAN. So NAN stands for not a number, and if we look in this unique, when we did the unique on the species ID, we can see that there's this. So I wonder if the len just counts all of the things in this array. Yeah, there we go. And then the n unique ignores this. Okay, cool. Thank you, Nathan and Henry, coming to my Googling rescue. So really, this is actually telling you just the length of the array from unique, whereas this is telling you all of the unique actual values, excluding any of the not numbers. But that was a good catch from you guys as well. So we can add that to our notes. And Rui's posted in the chat that if you ask it to include the not numbers, then that should give 49. So I will give that a go in the interests of completeness. Yeah, so that gives us 49. And what I've added to the arguments in the function here is saying dropping not a number is false. So that double negative basically meaning please include all of the not numbers, which we can see that there's one here. And that's why we get 49 out. Nice, mystery solved. So if we move on to the groups in Pandas, yeah, we often want to calculate summary statistics grouped by subsets or attributes within fields of our data. So for example, we might want to calculate the average weight of all individuals per site. We can calculate basic statistics for all of the records in a single column by using the syntax looking like this. So we get the name of the object, and then we get the name of the column, and then we use describe, which is a built-in function. And if we do this, then it gives us some basic statistics out. So we've got the count, the mean, standard deviation, minimum, we've got percentiles, and the maximum. And it also spits back out the name of the column that we've queried and what type all of the values then it have, and we can see that they're floats, which makes sense because some of these are non-integer numbers. We can also extract one specific metric if we wish. So now that you know what the describe function spits back out and what the metric names are, we can get them individually. For example, if we wanted the minimum, we can just take the name of the object, the name of the column, and then the name of the specific attribute that we'd like. And that holds for the other ones as well. So we could get a couple of things out one after the other. Right, but if we want to summarize by one or more variables, for example, sex, then we can use the pandas.groupBy method. Yeah, sorry, this only printed one thing out because the Jupyter notebook can only print one thing per cell, so that was my bad. Yes, once we've created a group by data frame, we can quickly calculate summary statistics by a group of our choice. So we're going to create a new variable called group data. And then the pandas function describe will return descriptive stats, which we just saw above. So mean, median, max, min, standard deviation, and count for a column in the data. It can only return summary values for columns containing numeric data. So if I ask it to do data. Try and type properly. So then we've got the separated by sex here, and then it gives us all of this data that we saw above for the white column. And then we can also get the, if we want just the mean out, then we do .mean and numeric only. So now we get the mean for each of the columns, for each of the numeric columns only split by female and male. So it's a very quick way to get some statistics on the data that we have. So the group by command is pretty powerful in that it allows us to quickly generate these summary stats. So we have an exercise now on creating summary data. So we'll probably give a little bit longer for this one, but if you can work out how many recorded individuals are female and how many are male, and then look at what happens if you group by 2 columns using this syntax, and then calculate the means, and then do part 3. Oh, okay, yeah. Maybe we'll have a break until, yeah, I'll leave you guys with this exercise and we'll condense it into the break. So I'll come back and I'll go through the answers to this at 11:15. But we'll be around, so you can still post in the chat if you need help with anything. Then you can just let us know. And yeah, we'll reconvene at 11:15. So yeah, take a comfort break in this time as well. Bathroom, water, etc. Okay, I hope everybody back and rested from the short break, and now we'll go over the exercise. I saw that somebody has come back after having to be away, so yeah, we're at the challenge summary data, which is just before the quickly creating summary counts in Pandas section. And we were asked to look at how many recorded individuals are female and how many are male. So we can use the first column of output from the grouped data.Describe count. That tells us there are 15,690 records for female individuals and 17,348 records for male individuals. But those numbers don't sum to 35,549, which is what we know is the total number of rows in the survey's data frame. So why do you think some records were excluded from the grouping? You can post in the chat while I run those numbers to see that they match this time. Okay, so one reason that they could have been excluded from the grouping would be if there isn't a record for whether that animal was male or female. And so those wouldn't have been counted. And then if we call the mean method on the data group by these 2 columns, then that will calculate and return the mean value for each combination of plot ID and sex. And then, of course, the mean is not meaningful for some variables, like the day or the month or the year. You can specify particular columns and particular summary statistics using the AG method, which is short for aggregate. So to obtain the last survey year median foot length and mean weight for each plot sex combination, you can use this command. That will then give you the statistics here. Okay, so hopefully everybody managed that, and we'll go on to quickly creating summary counts in Pandas. So next we're going to count the number of samples for each species. We can do this in a few ways, but we're going to use the group by method that we just learned combined with a count method. So if I create a new variable called species counts, and we're going to set that equal to the data frame object group by the species ID. And then record ID. Dot count, and then these, and then we'll get it to print the species counts. Break, because clearly it made my fingers not work as well as they were before. Okay, so now we get this, all of the codes for the species IDs and how many are tagged with that, so we can see. And then again at the bottom it tells us what it is that we've looked at and what data type that is, and those are integers because you can't have fractions in this. We can also do just counting the rows that have the species code like DO, for example, like this one. And we can do that command by typing in the following. So another group by ID or record ID. So the same as before, but then at the end we do the square brackets for indexing and then the code for the one that we're interested in. And then it tells us there are 3027 species recorded with this code, which we can see matches the output that we got from the full count set. Great. So we've got a small exercise of can you find another way to create a list of species and associated count of the records in the data? There's a hint here about how you can perform these functions on the group by data frames in the same way you can perform them on the regular data frames. Yeah, so I'll give you a few minutes to have a go at that. Okay, so we'll have a look at the solution here. So as well as calling count on the record ID column of the group data frames above, we can get an equivalent result by extracting record ID from the result of count called directly on the grouped data frame. So above we had done, we'd grouped them by this, whereas here we're just doing group by this and then count, and then putting the record ID in here. And it gives the same output out that we saw before. Cool. Okay, so now we're going to move on to we can also do basic math functions on this. So we could apply a mathematical operation like addition or division on an entire column of the data. So for example, we could multiply all of the weight values by 2 by two. Well, if we print it out actually as it is, and then do the same thing so we can compare and check that it's worked. Yeah, so all of these are not numbers, so obviously they can't be multiplied by 2, but then you can see where we did have 14, we now have 28, and where we did have 51, we have 102. So that's multiplied every result in the weight column by 2. So a more practical use of this, rather than just arbitrarily doubling everything, might be because you want to normalize the data according to a mean or an area or another value that you've calculated. Now we're going to go on to looking at quick and easy plotting using Pandas. So we can plot the summary stats using Pandas as well. If we do matplotlib inline, There we go. So now we have created a bar plot in one line using and we've got the species IDs on the x-axis and then the count on the y-axis. Using the matplotlib library, which goes well with pandas. We could also look at how many animals were captured in each site. So we'll make a variable called total count. We'll group them by the plot ID. We want the unique ones. And then we can plot that as well. So here the plot function is part of matplotlib, and then by kind we're just saying what type of plot we want. So in this case it's bar. There we go. So now we've got the ID number of each of the plots where the species were counted, and then the number of animals counted in that plot on the y-axis. So it's an easy way to have a visualization of some of the data. So now we're going to get you to make some plots in the plotting challenge. So this one's quite long, so it would be good if you were able, if you're not already got the web page open, then it would be good to. So we're going to look at creating a stacked bar plot where we've got weight on the y-axis and the stacked variable being the sex, and the plot should show the total weight by sex for each site. And there are some tips in this box. So if we can post a link to that in the chat. And then I'll give you 5 minutes to see if you can make this plot. And as ever, if you need any help, just post a question in the chat. Okay, it looks like Ray and Nathan have some debugging, and Ray's posted in the chat how to fix it if anyone else has the same issues. But we'll have a look now at the solution for making the stacked plot. So first we want to group the data by site and by sets, and then calculate a total for each site. I will do this as well, so you can compare your plots to mine, and hopefully we'll all have the same thing. Okay, so, and then we'll use unstack on the group data to figure out the total weight that each group sex contributed to the site. So and that shows output of, sorry, I hope you can see underneath the screen with the instructions. But yeah, so that gives us the plot ID, female and males. And now we can create a stacked bar plot with that data where the weights for each sex are stacked by site. So rather than display it as a table, we can just plot this data from this table as follows. So we'll do this plot. Who specify what SPC is first of all before I try to use it. And we can add some axis labels on it as well. And we'll do the x-axis as well. So if we do that, then we should get, so it's different colors to how that one was done. But if I move this out of the way, and hopefully you'll get something similar. So we've got the total weight and the plot ID, and then stacked by sex. Great. So the key points from this lesson is that libraries enable us to extend the functionality of Python by giving us more functions that we can use for our data. Pandas is a very popular library for working with data. And a data frame is a Pandas data structure that allows one to access data by the column, the name, or the index, or you can access the data by the row. Aggregating data using the group by function enabled us to generate useful summaries of the data very quickly, and we can use plots. Plots can be created from the data frames or from subsets of the data that have been generated using the group by function. So I'll add a little poll, and you can let me know if you manage to get a plot that looks like this. And if anybody didn't manage to or has any more questions around making these plots, then just pop something in the chat. And thank you, Ray and Nathan, for debugging this problem with the showing the plots in line. Yeah, so the unstack method moves the data from being in one big group into columns that are then plottable. And if you ask it to plot when they're not in plottable columns, then it will cause an issue. But yeah, you can see that by doing by looking at the data, your group's data, and then unstacking it and seeing how it looks differently. So we can just use the next 10 minutes or so for questions if anybody has any. We've now reached the end of the second part of the course, so I won't start the third one until after lunch. So we'll come back from lunch at 1 p.m. But so you feel free to go now, or Ray and Nathan and I will be around until 12 if anybody has any more questions about what we've done so far this morning. Otherwise, thank you, and enjoy your lunch if it's lunchtime where you are. All right, if there aren't any more questions, I will be putting up the whiteboard to remind you all what time to come back. And I'll see you all at 1 p.m. UK time.